Hi, my name is Todd Sharrard, and this is assignment 1 for Java JAC444. So you asked us to complete 4 methods. This is the first method that I did. It's called the palindrome class. In order to accept user input, we must do an import for the scanner class. So here is the name of the class. It must match the file name. Here is our main argument. Which the class requires. Not all classes, but this one is the one that's going to run, so it needs a main argument, right? So we declare a new object. In this case, we're declaring a new scanner object, and the name of the object is called scanner. This could be anything that you want. Then we prompt the user for an integer, and then we create a new variable from the prompt. From what the user entered, and it's an integer type variable. Then we run the method is palindrome with the user input, and then if it is a palindrome, we print out this is a palindrome, and if it's not a palindrome, we print out this is not a palindrome. So here is the method that we use. It's called isPalindrome, and it has a method parameter it requires an integer, and that needs to be and the return type is going to be Boolean. It's going to return true or false. So here we declare 2 variables. The original number is the number that we passed through to the method, and then the reverse number starts at 0. So in order to determine if something is a palindrome, and if it's an integer, you can do it this way. You can take the number, determine the remainder when you divide it by 10. So if the remainder, so if you take 1,004 and divide it by or percent 10 or remainder 10, the value will be 4. So that's how you're going to determine the last digit. And in order to, so then you take the 4 in this case, and you add it to reverse number. And in this case, reverse number is 0. So 0 times 10 plus last digit is 4. And now you've determined the last number of the integer that you entered. And then you run through that process again, but you hack off the last number by dividing it by 10. Simple math and simple method, right? And this will determine if something is a palindrome. So let's run this. Stop and run. There we go. Enter an integer. 852258. 852 is a palindrome. Let's run it again. 11223 is not a palindrome. Let's run it again. And 123321 is a palindrome, and then we're done. The next class we did is the smallest factors class. This one, again, we require the import for the scanner. We create the name of the class. The name of the class is smallest factors. And then within the class, we have our main argument. Okay, this class does not use a method. It basically just runs through the process to determine. So we create a new scanner object. We prompt the user for the integer, and then we create a variable called number from the value that the user entered here. So we do a little bit of exception or catching here to try to determine if the number is less than 0, because it's not going to work if it's less than 0 or 0. But we don't have anything like try or catch or anything like that, and that's how we should be doing it. Because you wanted the factors printed in decreasing order, we need to create a string, and then we're going to concatenate the values of this loop to this string, and by doing that, what we'll end up doing is creating or displaying the factors in decreasing order. So in order to do that, we determine if the number divided by the factor, in this case we start at 2, if the number divided by factor or the remainder of that expression is 0, then in fact we do have a factor. So that condition is true. Factor equals factor plus factors. This is where we concatenate the strings. the strings so that we can display them in reverse order. And then this is where we declare the new number so that we can run through the loop again, right? And that's how we will end up printing the factors in decreasing order. So let's run it, stop and run. Okay, and positive integer. So you said you wanted 120. There's 120 in decreasing order. Let's do 60. There's the factors for 60, 5, 3, 2, 2. And then let's do 88. And then there's the factors for 88. 11, 2, 2, and 2. So, yeah, there we go. That's the factors. The next class is the My Sorting class. Again, we need to import the scanner because we require the use of it. We create the name of the class as My Sorting. It has to be the same as the file name in our main argument here. In this particular class, we are going to use a method, and so we have the main argument here, and then we have the method down here. The method in this case is display sorted numbers, and the method signature, the access modifier is public, the modifier is static, and the return type is void, and the name of the method is there. That's display sorted numbers, and these are the parameters, and I need to control Z. These are the parameter lists that the method requires. So up here, we prompt the user for 3 double values. They can enter integers, but the system's going to accept them and cast them as doubles. And then here we print out the numbers in increasing order, and here we pass the numbers to the method, right? So in the method, in order to make it work here, we created a temporary variable. It's a double type. And then we run it through 3 conditional if statements. And this is pretty simple. It looks harder than it is, but basically the higher number gets stored in the temp variable. And then basically by doing that, if the higher number is in the temp variable, it will basically get cast into the proper position eventually, and you can run through the loop in doing that, and that's how it works. So let's run the My Sorting application. I think I need to go here. Okay, 3 numbers. So let's give it 88, 99, and 120. Should give you the same output, but it should give you the same output, but the values will be expressed in doubles, in double integer types, or double variable types. Sorry. Control Shift F10. Let's run it again. Let's give it 99, 10, 18, sorry, and 2. So there's the numbers in increasing order, and then let's run it one more time. And here's 3 numbers, 55, 44.1, and 22. And there's the numbers in increasing order. The last one, the last class is the scores class. We need to import the scanner again. We know what the scanner does, and then we have our main method here, and then we have a couple methods here that we use in order to determine the student's score. What's important in this example is score or best score. First, we must determine the best score in this method, and then in this method, we determine the student's mark, and it's kind of relative to the best score here, right? So if the student's best score is greater than or equal to, if the student's score is greater than or equal to best score less than 30, then the student gets a C. So in this case, we could have 3 students get 10%, 12%, and 15%, and all 3 students will get an A. walking through the main method here, again, we create the scanner object, we prompt the user for the number of students that they want, and then we create variables. We create the variable number of students from the prompt. Now we create a new array. This is important. So we're creating a new array called scores, and the array type is double. So a new double array, and the size of the array is going to be basically the number of students, which we determine through the prompt. So once we know the number of students, we create the array, and then we read the scores. So we prompt the user to input the scores for the number of students that they entered. Now we need to determine what the best score is, so we go to the best score method. Here we find the best score, so it's one of those, if score is greater than best, then if that's true, then best equals score, and you just kind of run through the loop. What's unique here is that we're using a for loop, and we're not using the long method, but we're using the short method here for the loop. And we can do that with the array because the array is score. So we determine the best score, and then in this loop here we assign the grade. And again, the grade, it's just basically an if, else if, else if, else if, else, right? So the last condition will be met if all the others aren't, right? So here we determine the best score in the method, and then here we run through a loop that's basically the size. The loop needs to run the size of the array scores, right? So and it will run 4 times. So, and then over here, yeah, here, so we assign the grade. There's the calling of the method, assign grade, and then here we're going to pass the first value in the scores array, or the I value in the scores array, and then we're going to pass the best score, which we determined in this method that I already showed you. So let's run it. Okay, enter 3 students, and again, we got 12%, 15%, and 16%, while all 3 students got an A. Let's do it again. Let's do something 88. Control Z, Control X. How do I get out of that? I think I can just rerun it here. Oh, and that's because I put this in here. Okay, let's see if that runs. Yep, enter number of students. So there's 3 students, 88, 33, and this one got 75. So there's the marks, and then let's run it one last time. And here we had 99. Oh God, I did it again. But I think you get the point. The class is running, so let's go 4 students here. 55, 65, 75, and 85. And there you go, because the 75 and the 85 were within 10. The last 2 students received an A. So that's about it. Just under 15 minutes. Thank you.